All right, so we've been able to look at all those different basic things with Python, object-oriented programming that is. This is not being fair to me. There you go, finally. And we've covered everything all the way to polymorphism. So again, it's time for us to face ambiguity. We're going to refuse the temptation to guess because there should be one and preferably one way, which is the obvious way to do it. So what questions do we have so far before we continue? Let's see if I can separate this side by side with our code again. So we were able to create a customer. We're going to start again with something else, something different to practice later on. But for the second part of this class, we're going to practice as usual. So what are we going to practice on? We're going to practice creating a class. We're going to create a constructor with private and public attributes. We're going to use getters and setters, just like we just did. But practice makes perfect. So I'm going to start again from scratch. We're going to do that part. And then we'll try using an object. You know, objects could be built in, as we've already known. The string class is a data type, the list class, and so on. And we can also import them when we start importing libraries, which have classes that are built in and also methods that are tied to those classes. We've been able to create an object. In this case, we did create two objects, customer 1 and customer 2. We gave them names and so on. But I'm going to do it in a different manner this time around. Okay, so let's start. What questions do you have before I get started? No question. So I'm going to start by creating a class. What I need to do in this case is I need to create a class. What I'm trying to do here is want to create. Let's use the car example. We started with the customer example. This time around, let's use a car example. We're going to create a car class, and then we should make that class to be able to have an accelerate method, a brake method, and maybe another method just to get the speed. Okay, and then we'll see what we can do by displaying this out there. So to get us started, we are in our day 8 folder. I'm going to create a new Python file by clicking on that plus sign. I'll give it a name. A suitable name for this would be car, right? Any objections? Everybody okay with that?
Yeah.
Awesome. So let me go ahead and, oops, I lost it though. So let's go back and do car.py. That is our car example. So we want to create car class. To do that, we use a keyword class. I think there should be a faster way of doing this, but that's fine. And car in capital C. Okay, it is a compound statement which ends with a semicolon. So we can start creating our constructor first. So our constructor, again, is known as an init, which is the constructor that takes place, that creates itself when you initialize that particular class. When you create a new object, this fires off immediately. So it's going to need to have a few things in here. For our car class, let's say we want to have attributes include what should we have for the attributes? Let's take a year. I cannot spell. Attributes include year, make, I don't know, maybe model. Let's go ahead and add model in there. And also the speed. Okay. So in here, we want to go ahead and add those attributes. The attributes will be year, make, model, and speed. Sounds good? So now that we've created those attributes, we need to go ahead and initialize them or tie them to the particular class in this case. So year should be equal to year. Then we create another one, make it private, make, get the make, create another one, make it private as well, model, give us a model. And finally, in this case, I'm going to try to make sure that our car does not start running right away. So when I create a speed, I'm going to set our speed to 0. Okay, everybody good with me so far?
Yeah.
So if we set the speed to 0, if I put my mouse over speed, speed is going to now become an integer or float. So that's the first thing I've done. I've created my constructor, but I want to be able to also define all those. Again, you don't necessarily need to have a get and a set method because we're not using any of that right now. But a few things we want to be able to do is we want to define some kind of acceleration. So if I go ahead and say I want my car to be able to accelerate, I'll create accelerate. I'll create a method that takes in, what should I say? A method that takes in that. And what I'll do is for the self.speed, I'm going to increase it. So whatever speed it has, go ahead and add 5. That's how you increment the speed, right? So this is coming directly from this. So self speed should be that, except I forgot one underscore. So if I'm starting from 0, my next speed will be 5. Is everybody okay so far? Each time you accelerate, you increase your speed by 5. Let's also go ahead and brake. So if we want to define brake, that particular self again, we're going to say self.brake. Instead of, I should have used decelerate, but that's fine. Instead of increasing the speed by 5, now I want to reduce it by 5. Sounds good? Next up, let's go ahead and figure out what the speed is currently. So we use a definition again to create that method, and we say get speed. That speed is acting on the same object once it's created. These two, accelerate and brake, these two functions or these two methods are not fruitful. They are void methods. They don't return anything. But this speed method is going to be fruitful. It's going to return to us self.speed. Sounds good? And this would be our blueprint. This is our class for the car. We don't need to do much else. We can go ahead and do get model, get make, and get year as well. That's totally fine. But if we don't need to get each one of those, maybe I can go ahead and create another function or method in here that says display car. Maybe display car info. And that works on self as well. Display car info should return. Do I want to return it? Nope, I should not return. Let's go ahead and just print. I'll go ahead and print f for car is of make. Let's go ahead and do self dot make. How do I want to describe it? Your car. Let me give it a year in here. Self dot year. So yeah, 2010 or 2020 car is of make, blah blah blah, and model. Excellent. This is not good.
Can you remove this white screen here?
Yeah, let me go ahead and do that. That's exactly what I was about to think. There you go. So again, we're able to have our, can you see clearly? Do I need to make it bigger? All good. All right. So I've been able to define my constructor. I have now 4 methods in here. The only get method is this one that gets the speed. Okay. So let's go ahead and add accessor or getter. The rest are just other methods that are making changes to the attributes or just displaying the attribute. So that's it for the car piece of it. Now, after doing that, you need to create a separate file. So once you've created this car file, you can have your program running on a separate file. So I can go ahead and create another file, a Python file, obviously, and say my program maybe .py. I should make this p a small p. So my program.py is going to be using that class. Okay. So if I want to use that class, the first thing I need to do is import it. So if I'm going to import, I have to have import car. Because it's importing this file right here. So the car now is just a module. This module, we've already defined it. It's a blueprint. I can use it in any of these pieces of code. So my first piece of code, I'm importing the car. Okay. So I want to also make sure that my code is modular. So I'm going to have a main method or a main function. So let's go ahead and define our main function. And say the main function needs to do a few things. First, we need to create an instance of a car, and we need to accelerate. Accelerate, let's say 3 times. And then we need to brake. Let's accelerate 5 times. Then need to brake 3 times. Those are some of the things we need to do. Code. Create an instance of a car. Accelerate 5 times, brake 3 times. What else can we do? Print out. Say display our info. When I created that display method, I actually did not I did not display the speed, but that's okay. We can go back and change that later. So in order for us to create an instance of a car, what do we need to do? Let's say the car would be my car, be equal to, since I'm importing car, I'm importing that entire file. So I'll have to say car dot, once I put a period, it starts giving me all the information that is present in that file. There is a car in the file, which is a class. So I can use that class to be able to create a car for myself. And in order to create a car for myself, think about the constructor. If I put in my parentheses, it tells me it needs a year, it needs a make, it needs a model, and it needs a speed. The speed I necessarily don't need to put it because it starts at the speed of 0. So let's give our car a year. The year in this case, let's say is 2022. And let's also give it a make. Let's call it a Jaguar. And a model, let's say F-Face or F-Type. Don't need to put the speed in there because the speed is currently at 0. Looks good. So now if we want our car to accelerate, let's go ahead and notify the user car is accelerating. Once we notify the user the car is accelerating, then we can go ahead and accelerate 5 times. So to accelerate 5 times, we can use a loop. We have been using loops before. So we say for, let's do ACC accelerate in range of 5, because that's going to give us 5 times, right? So for each time that we want to that, we're going to go ahead, my car will accelerate. As you can see, just with the period, it gives us all the different methods that are within that car file. Since it's a class, we can go ahead and also have some of these built-in methods. These are some of our attributes which are not accessible because of the double underscore. Okay, so what we want to do here is accelerate. Accelerate doesn't really take any inputs, so just that is good. But each time it accelerates, we want to probably go ahead and output that speed, right? So let's go ahead and print current speed. Current speed can now have information for my car, but get speed. Get speed was going to return to us what the speed is. So if we go back in there, I think there should be a way I can get to that. Oh, there you go. So once you type that out there, if you're not sure again what get speed does, if I right click on it, it says go to definition. If I click on that, it takes me to the definition of that code where I got it. So get speed is just going to return the speed. But in accelerate, I had already increased that speed. So now I'm writing my program. I have encapsulated all my data. Everything is out there. Abstracted all my stuff is out there. It's encapsulated within this class. And I can pull in just what I need. They don't need to figure out all that complexity. All you need to know is, hey, I can do this with this car. I can get the speed. I can accelerate and so on and so forth. Okay. So once we've done all of this, we can now go ahead and maybe get a new line and say, on accelerating. After you're doing that, let's print on accelerating, or let's just say cruising. So we have accelerated 5 times. Now, if we want to break 5 times or break 3 times, we're going to do something very similar. But this time around, instead of accelerate, we're going to do break. So in order for me to make it faster rather than type it, I can go ahead and copy that over. The car is now, or the car is braking. And then I'm going to do for, let's say accelerate, that's fine. The car is going to brake. The current speed, you still get it. Now cruising again. Is everybody okay with this so far? Is it too much? Am I going too fast?
It's too big, but we're surviving.
Okay, all right, let's try it. So now I want to display my car info. To display my car info, I can go ahead and just do my car dot display car info. That's possible to do because if I go back to the definition, right click and go to definition, I see that it's actually going to print it for me, so I don't need to print it again. Okay, so in here, that should be just fine. Now let's try to drag this up and execute it to see what happens. So here I'm executing my program.main, oh sorry, my program. To execute that, I definitely need to type in that call to call the function. So let's go ahead and call that. To call the main function, all I have to do is main, and it's going to call this function that I've defined right here. So the function is defined, you call it, and you're good. Within that function, you have a loop that's accelerating, you have another loop that's braking, and then you're good. You're print all your information out. So let's go ahead and execute this. Okay, good question. So my first issue is with line 25. Line 25 is calling the main function. Now let's debug it. Within line 25, we have a problem with line 5. In the car, blah, 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 blah. The module car has no attribute car. So what did I miss here? The module car has no attribute called car. And car is a class. What am I missing? Let's go ahead and see if I'm missing this. Okay, am I having all the attributes in there? 1, 2, 3. Car has 1, 2, 3, 4. It doesn't matter. I think it should be just fine. So where am I? Sorry, wrong one. So line 5 is the issue. The class car takes in a year, a make, a model, which is year, make, model, and speed. Let's give it a speed of 0 and execute that. It still says it has no car. What am I missing? That's very weird. String, integer, 1, 2, 3, 4. Okay, is it because I'm missing these? I don't think those are important. That shouldn't be in there. Yeah, make model. All right, let's try this out and see. I think I know what the issue might be. Okay, so the issue might be that I don't have this saved. Let's make sure I save it. Now that I've saved it, I should be able to run this. Yeah, that's probably what my issue was. Yep. So sorry about that. I finished writing my Python code, but I definitely did not save it. I should have looked at it. Each time you check up here, if you see a white dot, that should tell you your file is not saved. This is saved. Oopsie. This is now saved. This is now saved. So that's what the issue was. That's why I was unable to tell car, because that was not saved. So let's go ahead and see, what am I missing here? Expand this, accelerate, get speed. I keep forgetting each time I write this method, I have to use the opening closing parentheses. That's why I was getting that. It's giving me the location of that. Okay, so it's just telling me information about that get speed method rather than giving me the return value. So let's clear this out and try this again. Excellent. So we've been able to fix all our issues. The car should work just fine, and we have saved our file. So let's execute this. Again, executing it. We're going to have this break 3 times. Oh, I lied. This should break 3 times, not 5 times. So this should be 3. Let's start and collapse this. And very good. Now let's execute that. Execute. Trace back. What did I do this time? Okay, missing one required positional argument speed. That is correct. I need to add the argument for speed. And then execute that. All right, so we execute it. The car starts accelerating. The current speed is 5, 10, 15, 20, 25, and then you're cruising again. Once it's cruising, the car starts braking. It brakes 20, 15, 10, and we're cruising again. Now it displays the information about your car. Your 2022 car is of make Jaguar and model F-type. So if we want to make changes again to maybe 10, 20, 30 different cars have been created and they're doing different things, instead of going to each one of those cars and making changes to the speed, the way that let's not say the speed, the way that the car information is displayed, I have my program. I have 20 other teammates that are writing programs that are using that class. But now we want to change the way that the information is being displayed. As a programmer, you just have to go to one place to fix it. You know, that's why object-oriented programming is good, because it's easy for you to maintain. All we need to do then is go to our car program. In here, we want to change your year of the car is of make blah, 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 blah. Maybe go ahead and add another print statement in there. And oops, let's say print. You are currently cruising at, and give it a speed. So here we want to use self dot speed. That's good. Now we made a change just in one place. Remember to save your changes, because if you don't save it, it's not going to be reflected. If I execute this time, and let's change my car to a Honda, and this is a Civic, and let's start our speed at 10 this time around. Maybe make it a 2020 Honda Civic. Execute that. Now we have your car is accelerating. Oops, sorry, wrong one. I should scroll down. Your car is accelerating, current speed, blah, 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 blah. Yeah, so this 10 did not really matter. The 10 did not really matter because in our car class, we always set the speed to 0. Okay, so we start accelerating from 5, 10, 15, 20, 25, and now we're cruising. So it tells us the new updated information. It also includes what speed we're currently at. Sounds good? Yes, Mr. Evan.
So rather than changing to 100, you could have just created another instant.
Exactly.
Okay.
Exactly. Rather than changing that, we could have gone ahead and said, okay, maybe I didn't want to change all of that stuff, right? I want to create another car. New car. New car will now be car.r, and it will have all those different stuff that I had earlier. 2020. And let's change it to Accord and give it a speed of 2. Now we have 2 cars. Again, we didn't have to go back and rewrite this car class. So that same class is being used to create all of this stuff.
Okay. So the key the speed parameter is private.
Yes.
Right. But the program requires us to enter that argument.
Yeah. So it forces us to enter that. We could have made it optional, just like we make our, remember when we talk about functions?
Yeah, exactly. That's what I was coming to.
Then it's going to be optional.
Okay, cool.
Yeah. So let's do that. Control save, and then go ahead and take this out. We should be good now. If we execute that, it runs just okay.
Yeah, I think it makes sense to make it optional because you don't want to enter an argument that doesn't, right?
Exactly. That's going to be overwritten anyway. Yeah. So at least now you're seeing the big picture of how we were able to learn variables. We use those variables to tie them in here to properties or attributes. We're able to learn functions. We use those functions to be able to create methods for our objects. We use loops. And when we came to our main program, we're able to use those loops to do all these multiple times. And we can do all of that and create an object-oriented programming. You know, this can be created and then packaged together into a folder and decide and say, hey, I created a library for cars. So that's what is being done out there when you have a library that's created for you to be able to call on web pages, able to create our own objects, right? We've been able to create our class, having those attributes and methods in there. We created a constructor with private and public attributes. We use those getters and setters that are using the same class or the same object, acting on the same object, which is self. And we'll be able to use more objects also in the next class, because our next class, we're going to look at libraries and frameworks. So some libraries that we're going to import, and we're also going to look at built-in. I think we did look at built-in ones with the string and the list. And we've been able to create objects. We created the 2 cars, the my car and the new car. Earlier on, we created customer 1, customer 2, which are all built from the class, the blueprint, the template that we had created. We saw some errors and we're able to debug those things too. So all in all, we've been able to discuss all those different programming patterns. We also looked at the basics of classes, or basics of objects, which included classes and objects, and also looked at some principles of object-oriented programming. So at the end of the day, encapsulation, abstraction, inheritance, and polymorphism were some of the things we looked at, and debugging as well. So final call, what questions do you have? I know we're a little bit over time.